Hey everyone, today we're going to look at the sine law and the cosine law. What's important to understand is this is trigonometry for triangles that are not right angle triangles. That's pretty well it, and with this we're going to prove what it is that we're doing and derive some new equations that we can use on specific types of triangles. So let's start with our sine law. Sine law works a little bit like this. If we have a triangle, we can section it into two right angle triangles. And from here, we can look at, first we'll look at angle B. Sine of angle B is going to be equal to x over a. So x represents the height of this triangle, and a is the hypotenuse length of this right angle triangle here. So that's pretty standard. Like, sine of this angle should be opposite over the hypotenuse. That's very, very, very well known by us at this point. Let's rearrange in terms of x. A sine b is equal to x. And then we're going to do the same thing for a different angle. We're going to do sine of a. And the sine of a, well, that's going to be equal to x over b. And we rearrange here. We have x is equal to b sine a. Okay, so both of these are the same x quantity. So this x is indeed equal to that x. And so we could set a sine b equal to b sine a. So a sine b is equal to b sine a. And rearranging, we get the relationship that sine b, sine of angle b over b, is equal to sine of angle A over side length A. And we could easily have done this for angle C and side length C. So the equivalency would also show that sine of C is equal, or sine of C over C is equal to sine of B over B. These are all equivalent to each other, and this is the sine law. So right here. That's it. So let's actually do an example here. Okay, so example 1. So we have a triangle, and we have these particular measurements. We have that this angle is 30 degrees, and we'll call that angle A. Side length A is equal to 15. Sorry, and this will be angle B. C, and side length B will be equal to 10. So all of these you have to have a little bit of information given to you in order to use the sine law. So what we can do here is solve for angle B. So that's what we would like to solve for. What is angle B? So let's put together sine B over B, and then we could set it equal to either sine C over C or sine A over A. We don't have any information about C, either its angle or its side length. So we're going to set it equal to sine A over A, and we actually happen to have both of those quantities, as well as the side length B. So these are questions that are usually pretty well put together for you to solve. So sine of B over 10 is equal to sine of 30 over 15. So sine of B is equal to 10 sine 30 over 15 if we multiply both sides by 10. Now that being said, sine of 30 is a half, so half of 10 is 5. So we have sine of B is equal to 5 over 15. And so B is going to be equal to the inverse sine of 1/3. That's 5 over 15 reduced. And so now we can grab our calculator, and inverse sine of 5 over 15, or just 1 over 3. So if B is equal to 19.47 degrees. Okay, so that is our angle B, and that concludes our first example. We will try another example. We'll do this on another page. So we have example 2. We have angle A, which is 150 degrees. We have angle B, which is equal to 10 degrees. And we have, by default, angle C, which is equal to 20 degrees. So often that can be given to us. It can also be something we have to solve for, but that's just all angles in a triangle add up to 180. And we'll have that this side length here is equal to 2. So what do we want to solve here for? We'd like to solve for the side length of A. What is the side length of A? And the reason I bring this up is let's kind of solve for A and see how we do that mathematically. So we have sine of A over A is equal to, I think we should do sine of C over C, because I have that length associated across from angle C. Okay, before we do anything, a neat thing about the sine law is that it can be kind of tricky to solve for the side lengths since they're on the bottom of the fractions. It can get confusing. You can mess that up easily. So a little trick that you can do is actually just flip the fractions. So long as you do it to both sides, it holds the same equivalency. So we can transform this equation into A over sine A equals C over sine C. It becomes a little easier to solve. So let's plug everything in. I'm solving for a. We're dividing by sine of 150. It's equal to 2 over the sine of 20. And so therefore a is going to be equal to 2 sine 150 over sine 20. So we get our calculator out. 2 sine 150, well, that's just 1 divided by sine 20. So we get 2.9238. So that would be our a value. I'm just going to say 2.92, but if I use it in further calculations, I'll keep the number on my calculator stored and ready to go. So with that, let's actually use that value to solve for side length b. So we're trying to solve for all the sides of the triangle here. So we have a is roughly this number here. And then finally, so kind of separate this process. We can say b over sine of 10 should be equal to a over sine 150. So we should have that b is equal to a sine 10 over sine 150. And so what we'll do, we're using this a value here. We're going to take that, multiply it by sine 10, and then divide it by sine 150. We get b is equal to 1.0154. So we'll say 1.015. We'll just round that to 1.02. So what we also could have done, and this is alternatively, is said b over sine 10 is equal to, instead of a over sine 150, we could have done c over sine of 20. When we solve for this, we do 2 sine 10 divided by sine 20, and we get the same answer. So that equivalency holds true. 1.0154, so that's that same decimal number. So you can use either way. There's often lots of different ways to solve when we're using the sine law and the cosine law. Okay, so that concludes our sine law practice. Let's take a look at the cosine law next.